Below are three coordinate axes. In the middle is a function that is f prime of x, a derivative function. Your job is to sketch f of x on top and f double prime of x on the bottom. I'm looking for rough sketches only. However, I do want to see maximums and minimums and inflection points in appropriate places, that the functions are positive and negative appropriately, and that they have the correct concavity. If possible, assume f of 0 equals 0. So let's start in the middle. So this is the function f prime of x. So I'm going to label this with f prime, but I'm actually going to label it first with a g. So we're going to come back to the f prime right now, but this is just a full-fledged function, and I'm just going to call it g. And then the function that we're interested in below is supposed to be the derivative of this one, right? We're trying to graph f double prime here, but that's really g prime. So again, I'm going to ignore the f part, and I'm just going to think about g here in the middle and its corresponding derivative graph here at the bottom. Okay, so let's take a look at g. We got some facts about g. First facts relate to where g is increasing and where g is decreasing, and it looks like g changes that behavior right here. And so to the right of that spot, g is increasing. And so that means that g prime has to be a positive number. And to the left of that spot, g is decreasing. And so that means that g prime is smaller than 0. It looks like g gets pretty close to being flat right here, but I don't think it ever actually gets flat. I think even at its shallowest, it's still decreasing a little bit there. But it is flat here at the bottom. Okay, so we've got some basic information about g prime, but we're going to go a little bit farther. We know where g prime is supposed to be positive and where it's supposed to be negative, but we want to also talk about where it's increasing and decreasing. So let's next take a look at the concavity of this g function that's pictured. So this g function is concave up from the beginning until maybe here-ish. And so we'll say g is concave up. So g prime is increasing until we get to around -2. And then g is concave down for a little while, like here, and then maybe until right around there. And so we'll say g concave down. And so on that interval, g prime is decreasing. And then g becomes concave up again, and I think it's concave up the rest of the way. And so we'll say g concave up. So g prime is increasing. So let's see if we can put all this together in one coherent sketch of g prime down in the bottom axes. So remember, the first thing we said was in red and purple. We need g prime to be less than 0 and then greater than 0. So I guess we should graph the spot at 0 at 2.4. So g prime, which we're going to do here in green, it's exactly 0 at 2.4. It's up here to the right of 2.4 and is down here to the left of 2.4, but we got to draw something more precise than we just did. So now we're going to talk about g prime, whether it's increasing or decreasing. So you can see that until we get to around -2, g prime is increasing, and then between -2 and around 0.4, g prime is decreasing. So let's start marking some of these. So -2, so we need to be increasing to the left, and then up until 0.4, we need to be decreasing, so in between decreasing. And then finally right here it says g prime is supposed to increase after 0.4. So we've got the real sloppy green squiggles telling us where the function g prime needs to be below the axis and where it needs to be above. And now we're just going to incorporate that together with this increasing, decreasing, increasing stuff. So let's give it a shot. I need to erase this. So we need to be increasing, decreasing, then increasing, and we have to hit that dot at 2.4 on the x-axis. Okay, so we got to go increasing, then decreasing, then increasing, and hitting the dot. Let's make this turn happen a little bit earlier. I think that's wonderful. Okay, and then to the right, after we hit the dot, we just need to continue to increase just like we were. So something like that. Okay, so that's our graph of g prime, but really it's f double prime. So we're going to erase this now and call it what it is, f double prime. Okay, coming back up here now, I'm going to erase all of this stuff, and now we're going to change our perspective to one of an antiderivative. So let's call this thing what it was called in the beginning. No more G stuff. This is now full-fledged F prime. And in the blank grid at the top here, we are going to graph F. Okay, so let's think about some information that we know here about F prime. So let's first look at where F prime is positive versus negative. So it looks like F prime changes between positive and negative at roughly those points. So that means any place to the left here, since F prime is positive, F must be increasing. And then same deal over here to the right of 3.8 or whatever that number is. Again, F prime is positive, so F is increasing. And then in between these two x-intercepts, F prime is negative. It's below the x-axis the whole time. And since F prime is negative, F must be decreasing. So that's a lot of information already. Let's go ahead and start plotting stuff. So we got 0.8 and we got 3. Am I doing this right? 0.6, maybe 3.9. Negative 0.8 is here and maybe 3.9 here. And we said that F was going to be increasing and then decreasing and then increasing. So increasing until we get to there, and then decreasing until we get to there, and then increasing the rest of the time. Something like that. But I've drawn some things in here about concavity. I guess really I should have said something really rough and say increasing and then decreasing and then increasing. But we're supposed to try to make this thing hit at the origin. So why don't we take that into account right now, right? I could have started this thing way up here. As long as it increases, decreases, and then increases again at the right spots, would be okay. So how about we start it at a spot where it actually looks like it goes through the origin. So increasing, let's try this again. Increasing until here, decreasing through the origin now until we get below the, the 3.9, and then increasing the rest of the way. Okay, so all that's left now is to think about the concavity of F, and the concavity of F has to do with the increasing, decreasing nature of F prime. So let's look at where F prime is increasing versus decreasing. So F prime here in the beginning, F prime is decreasing all the way until we get there. And because F prime is decreasing, F is concave down the whole way. And then for the rest of the graph, F prime is increasing. And so that means that F is concave up the rest of the way. So we need to draw something that is concave down until we get to around 2.4 and then concave up. So all we're going to do is smooth out this purple thing here and make it so that it changes concavity right around 2.4, right there. So we need to be concave down in the beginning and then concave up after the 2.4. So concave down and then concave up. So we're going to go up like this, hit the origin. I'm actually going to erase all right, I'll continue and then I'll erase it in just a second. So we're going to hit the origin and then we're going to change. So we've been concave down this whole time, and then we're going to change to concave up right around there. So now I'm going to try to erase all this, hide all of our evidence, and draw our final sketch here. So I think it changed it there. Okay, so we needed to be increasing until we got to above the 0.8 and concave down the whole way. And then we're going to keep being decreasing here, concave down until we get to right around 2.4, and then a subtle change to concave up, but still decreasing, and then increasing once we get past the 3.9. And so this right here is the graph of F.